Hello everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it, pause the video, and come back. Look, I think I can make it bigger, can I? Maybe not. Maybe not. No, I want to try to make the screen bigger, but I can't. Okay, let's go. Which of the following is equal to the value of the sign of that weird thing, pi divided by 2? Well, with knowledge of trigonometry from algebra, you recognize that the pi over 2 is in units of radians, and they're asking, and that represents the radians of an angle, and they're asking what is the sine of that angle, and 2 pi radians make up a circle. There are 2 pi radians, basically degrees, but they measure in radians in a circle. So pi over 2 is a quarter of 2 pi. See, 2 pi over 2 is 2 pi divided by 4 is pi over 2. So that means this represents a quarter of a circle, and you measure circles counterclockwise. So this is a 90-degree angle if we go back into angles, because circles and angles can be measured 2 ways. Oh, yeah, degrees. Oh, did I? Okay, degrees, right. Thanks, Seth. Okay, yeah, so we measure we can measure degrees in both angles and radians. So now we're going to the
You can measure angles in both degrees and radians.
What did I say?
You said you could measure degrees in both angles and radians.
It's been a long week. You could measure angles in degrees or radians, just like you can measure temperature in Fahrenheit or centigrade. Okay, anyway, so we have a 90-degree angle. Now, what is this whole thing about a sine? Well, people with knowledge of what's called the unit circle would know that the unit circle are the x and y values of the different angles, assuming that the radius of the unit circle is 1. And this is an x and y. Now we're back to what they call Cartesian coordinates, just the xy plane that you graph, normal graph paper. Now, this is a 90-degree angle in degrees, pi over 2 radians. Right, exactly. So we start here, we go counterclockwise, and we end up here because it is a 90-degree angle. Okay, what are the coordinates of that point? The coordinates of that point here, and this is actually a y-intercept. The coordinates of this point are 0, 1. So how does that help us in our problem? Because the sine of the angle is equal to the y coordinate. Oops, too many O's. It's equal to the y coordinate of the point on the unit circle that the angle hits. So, the y coordinate of the unit circle, to change color, is 1, because this is x, y, which means that it's equal to 1. Right. And it's equal to 1. That's sort of a mess. Whoopee, right, exactly. That's equals 1. So the other way to do it is to recognize that pi over 2 is 90 degrees. You have a calculator. I think the calculator will do something.
No, I'll use a calculator.
I know, I'm just going through, of course, but I'm just going through all the different approaches to do it, because that's what we do. You could type in the calculator sine of 90 degrees.
Yeah.
I'm not sure if the calculator on the digital SAT will be in radians. But God forbid you keep your calculator in radians, which we do not think you should do, but some calculators can be in radian mode. You give it sine of 3.14 divided by 2, and you would also get 1. If the calculator is in radian mode, but don't put the calculator in radian mode. Very dangerous.
Yeah, well, my approach was to immediately imagine the horizontal line origin of coordinates and the thought that this kind of angle, a so-called straight angle, is pi radians.
Right. Half a circle.
And therefore half of the pi radian angle is a pi over 2 radian angle, which so this line goes vertically. And then I realized that the idea that in general, the second thing is that when you have a unit radius, the length of the line, the length of the perpendicular opposite the unit radius is the sine of the angle.
That's right.
So I thought of these two things, and so I thought that the sine is as vertical, the length of this vertical thing, which is 1.
Yeah.
And so my eyes went immediately.
Right. Well, the length of this horizontal thing, the length of this horizontal thing is also 1.
So but that's not sine of pi over 2.
It's not just length; it's where it is on the unit circle. Not just the length; it's a vertical length. It's a horizontal length. It's a vertical length of 1.
The vertical line is the unit line. The vertical unit length is the sine of the right angle.
That's right. The reason why it all works is because they sort of fudge the hypotenuse. They make the hypotenuse 1, which means that when you divide the sine, which is, as Seth said, opposite over hypotenuse, that really works out well because the hypotenuse is forced to be 1. So the sine is just equal to the opposite.
Yeah, that's easy stuff. Well, again, I think it's a good idea to just to keep part of your math knowledge. Part of your math knowledge is that the radian measure of angles is such. What is pi? Pi by itself. Pi by itself, what does it mean in terms of angles? Directly, it means the magnitude of a counterclockwise angle that is a straight angle. That's what angle pi radians means.
And that is something you should know.
Yeah. And so that tells you a pi. It does. It's to think about what pi is in terms of 2 pi is an extra mental step.
Right. Oh, I see. I'm more of a 2 pi person.
I'm a 1 pi person.
That's exactly
2 pi's are fattening in one sitting.
I don't know. I like 2 pi because I remember the formula: the circumference is equal to 2 pi r. So. That sort of sticks with me. So therefore, I like to know that the whole circle is 2 pi. But it's personal choice. I don't want to say half the people, but a good number of people say 2 pi makes the whole circle, and a bunch of people like Seth who say a pi makes a half a circle. So
I've read recently that there was a little bit of controversy and a bit of an arbitrary consensus for the special name and letter, special Greek letter pi, for it to mean, the measure of half a circle, the angle measure of half a circle, or a whole circle.
Oh, it's a whole circle.
And so in mathematical formulas, 2 pi and pi kind of appear almost equally, equally frequently.
Hmm. But they
And
represent that.
many basic formulas that would be simpler if they omitted the two
Hmm.
by defining pi to be twice as much as it used to be defined.
Oh. Oh, I see. Right. You mean you're right. You could have defined pi, you could have defined that number to have been half a circle, which would have been 1.57
Yeah,
instead of
yeah, yeah,
3.14. Yeah.
yeah.
So that's sort of interesting, I guess. So these, but
So,
these,
in math, there are some things are arbitrary, and other things are inescapable.
hmm,
What is inescapable is that the circumference of a circle is proportional to the radius.
that's right. Yeah. And the constant of proportionality is
There's a
pi.
constant
Right.
that such that the circumference of a circle is that constant times the radius.
Right.
Yeah.
And they
I
decided to
must,
call that
however,
pi.
that is a property of a flat space.
Hmm.
In a curved space, the relation between the circumference of a circle and the radius is not a constant proportion.
Okay. Now we are above everyone's level. So,
Well, Einstein is at that level.
yeah. Yeah. But
He says not everyone. As Einstein is part of humanity of everyone.
yes, but we have to stay focused on what we are doing here, as opposed to doing
Nah.
everything. If you do everything, nothing gets done. We have to stay focused on what we're doing, and we are doing problems that are on the mat in the United States, America SAT given by the College Board, and on that level, they're not talking about curve space. So, but talking of getting back to this level, there are certain things you really need to know. Oh, there's certain things this problem is telling all of us you need to know on the SAT, which is a little bit of basic trigonometry, including the unit circle. And the unit circle is generally done in Algebra 2.
Mm.
Let's just hope in Algebra 2 you take the SAT before you do it in what's 11th grade in high school in the United States. So, I guess that's it. You have to know points about what you have to know unit circle stuff. What radians are, what a measure of radians is, what the points are, what the basic points are on the unit circle,
Mm.
How to calculate the sine and cosine of the basic points. When we say the basic points, those are the angles. There's a special name. It's probably a special name for those angles: the 30-degree angle, the 45-degree angle, and the 60-degree angle. Those are basic. Uh,
Oh.
Those are the angles that are basically those are called the unit circle angles, and those are the angles that you should be aware of. What the sine and cosine is of those, and this happens to be the sine and cosine of a 45-degree angle. So they threw that in there. Okay, I guess that's it. As we go on, maybe we'll hit more unit circle problems, and we can do more unit circle. So I guess that's it. Oh no, let's check the answers. Okay, let's see how they do it. They probably invoke unit circle stuff. Okay. Let's see how they answered the question. Only 4 steps. Notice they drew a unit circle. Recall that if theta is an angle in standard position, point P, where the terminal ray of the angle intersects unit circle, is the cosine and sine. Oh, we forgot to say that, but Seth said it. All they're saying is what we said, is that any point you have on the unit circle, this point here in x and y coordinates is cosine of theta, sine of theta. This point also is x and y. So it's got x and y coordinates. The x coordinate is the cosine of theta, the y cosine of theta, and this should be a 1. This should be a 1. Please put a 1 there for the radius. Okay. Then say the angle pi over 2 is shown in standard position. Yeah, but they don't really say much about how they get that. Note that the point intersects the point 0, 1, like we did, and it is the y coordinate. Right? So it's basically the way we did it. There's really just one Well, you can look at it from different points of view, but it's essentially the same point of view. So that's it, right? What is
Yeah.
that saying? Light, light, light blue. Light blueberry. Oh, yeah, it is a light blueberry. That's thinking food. Light blueberry pie. Very cute. He's putting in the blue in the pie. Yeah. Yep. 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 They 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 also maybe. Oh no, I drew that. I drew that in. Okay, I'm sorry. Well, if I drew that in, I'm not right. I have to put in the angle theta, don't I? Okay. So that's just being silly as he usually does. Like blueberry pie. That looks like a Pac-Man. Yum. Yeah, it's just that's like a Pac-Man. Yum eating. Okay, let's not waste everyone's time. So I'm Joel. I'm a PhD in mechanical engineering from Columbia University. My brother Seth is here. He has a PhD in math from MIT. He's a professor emeritus of computer science, retired now, and we are here to hopefully offer different approaches on how to do specific SAT questions. When appropriate, we make a distinction between how to do it as if it was a question on a normal test, as opposed to a question where you got to do it as fast as possible, which is appropriate for the Math SAT. We also advocate going to Khan Academy. They have 2 courses online that help you prepare for either the digital or non-digital. Each course has 600 or 700 questions on math, probably English as well. It's good to take those classes. They tell you essentially what is on the Math SAT. You study what's on the Math SAT using those questions, and then you go back to the College Board and take the practice tests that they offer. So I guess that's it. Please like, dislike, give comments on our videos, and if you have any SAT math questions, email them to us at satmathquestionoftheday@gmail.com. Guess that's it, right? Okay,
Yeah.
like blueberry pie to eat up. So hopefully everyone can enjoy some blueberry pie. Okay, everyone, have a great day.